All right, what up, everybody? Today we're going to be talking about parts of a circuit and then how to measure some important qualities of a circuit. So, we have, circuits are kind of complicated. There's wires, wires kind of snake around in weird directions. And so we have to have a way to draw circuits so that it looks simple and we can kind of look at the drawing and see what's going on in the circuit. So that's what we're doing. Um, So here are some symbols that we'll have in our drawings. These drawings are called circuit diagrams, and you'll be seeing them throughout this unit. All right, so a wire is just a straight line. A battery or any type of electric power source are going to be these alternating long lines and short lines. Okay, and so that's a battery. And then a light bulb, kind of looks like a light bulb if you look inside when it's off. Then a switch. Switch is when you can open the circuit, causing it to turn off, or close it, causing it to turn on. All right, so switches will look like that in our drawings. Okay, so this is a simple circuit where you have one power source. Maybe you have a battery hooked up to a wire that goes through a switch to a light bulb, then another wire going back to a battery. And it doesn't matter if the circuit is a rectangle in real life, right? A lot of times, with the wires and everything, it's not going to be a rectangle, obviously, but we'll draw it like this to make it look simple um, so we can analyze it better. Okay, and then if the switch turns on, there you go. There you have a circuit. This would be a working circuit now because the electricity would leave the battery, go around the circuit through the light bulb, and come back. With two light bulbs and the switch is open, it looks like that. Two light bulbs and the switch is closed, meaning the electricity is on. It looks like that. Okay, so we're going to be measuring voltage, and voltage is a measure of how hard electric charges are being pushed through a circuit. Um, it's determined by what type of battery is being used. Okay, so a different battery might give you different voltage, but once you have that battery, nothing else is going to determine how much voltage is going through the circuit. So you can switch up the light bulbs, the wires, whatever. Still, the total voltage for that circuit is going to be based on what battery you used. Okay, and the measurement for voltage is just volts, or a V for short. Okay, so this is how you measure the voltage, and I have another video available if you want to see me do this, but basically we have a circuit hooked up here where a wire is going into this electrical box, and the other side of the wire is going to clamp onto some Christmas lights, right? Electricity will go through the Christmas lights, and then this orange wire will clamp onto the other side and goes back into the electricity box. Okay, so that would cause electricity to flow through the Christmas lights. But we have two other clamps. We have a black one here, and we have a red one. And both the black and the red one belong to the voltage probe. Okay, so you have to put one on each side of the lights to see how much voltage is being used up by the lights. Okay, and the voltage being used up by the lights should be the same as the voltage being generated by the box itself. Okay, and so obviously this box will be this sensor box down here will be plugged into the computer, and the screen should show you how much voltage it is. So you're going to do that. Okay, another important measurement is current. Current is a measure of how much electric charge passes through a wire. All right, so it's not how fast. Some people have the wrong idea that it's how fast the electric charges are moving. It's not how fast, it's how many are moving through one part of the wire in any given time. So you can imagine you take a little cross section, you put a little line across the wire, and on this line, someone was counting how many electrons went by every second. Okay, that would tell you the current. Current is measured in amps. 1 amp is 6 to the 10 times 18 power electrons going through each second. Okay, so a huge number of electrons pass through in 1 second if you have 1 amp. Now, an amp is actually enough to kill you in the wrong situation. So we won't be dealing with whole amps. We'll be dealing with probably milliamps of electrical current. Okay, so the setup for measuring current is a little bit different. You still set up the Christmas lights and the power box the same way, but you have to break the circuit wherever you're measuring the current. Okay, so if you're measuring the current right after this last light right here, you have to unhook it from the power supply on this side, and then this red probe belongs to the current probe. Okay, so they'll up right here, and the other part of the current probe is going to hook up to the Christmas lights right here. So electricity has to go through these wires, through the Christmas lights, and the electricity is forced to go through the measuring device and then back into the box, right? And if you know it's working because the Christmas lights will light up again. And so, of course, this box is hooked up to the computer, which tells you the current. Okay, so what you're going to do today for your assignment is you are going to measure the voltage, and your teacher will have a string of 4 light bulbs, a string of 3 light bulbs, a string of 2 light bulbs, and a single light bulb. And so you're going to measure the voltage across each one and the current through each one. You're going to do this when the voltage is set to low, and you do it again when the voltage is set to high. So you'll notice on the box there's a little knob, and you go from, if you want to do low voltage, you do somewhere maybe in the middle, and then you want to do high voltage, you turn it all the way to the right. And you'll see the Christmas lights will get dimmer or brighter. Okay, please plug in to these two right here. It should say 3 amps. Oh no, it should say 0 to 5 volts, right? And maybe some other boxes that might say 6 volts, depending which one you're using. Do not plug into anything higher than that, because that would cause too much electricity to go through these things, and we could break some of the equipment. Right. So you measure the voltage and measure the current with when the voltage is turned on low for the 1, 2, 3, and 4 light bulbs. Then turn the voltage on higher and do the same thing for 1, 2, 3, 4 light bulbs. You're going to write this chart in your journals, and you're going to leave 2 columns with question marks, because we're going to learn about 2 other important qualities tomorrow, and you're going to put those in there. All right. So good luck. Hopefully you enjoy the lab and get that done today.